So to simplify this first one, first of all I'm going to gather together the like terms. So I've got an x minus 3x, so I'm just going to keep the 5x squared there, 5x squared. If we've got 1x minus 3x, we've got minus 2x. Now, looking at b, we've got every one of these has got an a and a b and a c. The highest power of a that I can take out is a, and then every one of them has a b squared, so I'm going to take out a b squared, and then they also all have a c cubed. So what I'm noticing is I've got one a b squared c cubed, another one, and two more, so I have actually got 4 a b squared c cubed. You can only add things together if they're exactly alike, and these are all in B exactly alike. For the next one, what I do is when I'm multiplying, I first of all look for the numbers. I've got just a 2. And then I'm going to go along and I'm going to get the a's and times them together. I've got a times a to the power of 6 times a. So I've got a to the power of 8. I've got b squared times b, so I've got b cubed, times b, I've got b to the power of 4. C times c cubed is c to the power of 5. Now for d, almost anything in the whole world to the power of 0 equals 1. And that is the answer. And that's actually something that you just sort of need to know. Right, so when you've got a situation like this one for E, where you've got a power to a power, another way to look at this one is like xy cubed times xy cubed times xy cubed times xy cubed. So we've got x to the power of 4. And then when we're multiplying bases with powers, we add the powers. So 3 and 3 is 6, and 3 is 9, and 3 is 12, x4, y12. A quicker way to do that is to just work with the x, and it's going to be x to the power of 4, and then y cubed to the power of 4 is going to be y12. The square root, okay? We're allowed to split it up. So let's split it up. Let's find this. When you're multiplying things together, you are allowed to split them up. So we're going to find the square root of 25 times the square root of x to the power of 4. Square root of 25 is 5. Now, the thing that was times by itself to give you x to the power of 4 is x to the power of 2. Because if I go x to the power of 2 and I square it, I'm going to get x to the power of 4. So working backwards, if I take x to the power of 4 and I square root it, I'm going to end up with x squared. Now for g, when you add fractions, you must have the same denominator. So I'm going to multiply the two numbers at the bottom together. So 5 sevens are 35. And I'm going to rename both fractions with a denominator of 35. To go from 5 to 35, I had to times by 7. So 3 times 7 is 21. 3x times 7 is 21x. To go from 7 to 35, I had to times by 5. 7 5s are 35. Have to do the same to the top. 4x times 5 is 20x. Okay, now that they've got the same denominator, I can actually add these both up. So 21x plus 20x equals 21, and 20 is 41x's over 35. Our next task is to multiply fractions. Multiplying fractions is good because all you need to do is you need to just multiply across. So I'm going to go 5x times 4xy. I'm going to get 20, 5 fours are 20. X times x is x squared y over 9 times 6 is 54 y squared. And I can simplify that even further by dividing by, we'll divide by 2. If I divide, I'm going to write divided by 2. So if I divide 20 by 2, I get 10. So 10x squared y. If 54 is divided by 2, we get 27 y squared. But wait, there is a y in the top and a y in the bottom. Let's divide the top and bottom of this fraction by y. So I get 10 over 27. If we divide the top of the fraction by y, we're going to just end up with x squared. If we divide the bottom of the fraction by y, we're going to end up with 27y on the bottom. Next one, when you are dividing by a fraction, you turn the fraction upside down so we get its reciprocal, and we multiply by the reciprocal. So 2x over 3y times 18y squared over 8xy. What I think I do is, I think that I'll do the multiplying first. That's what I'll do. I'm going to go 2 times 18, I'll get 36. X times y squared, because I'm just multiplying across. 3 times 8 is 24. X, y squared. X, y squared. Okay, now I can divide the top and bottom of my fraction by xy squared. So I'm going to end up with 36 over 24. And when I look at those numbers, I can divide them both by 4. So I'm going to divide 36 by 4, I get 9. 24 divided by 4, I get 6. Ooh, wait a minute. We can divide even further. If I divide the top and bottom by 3, I'm going to get 3. 9 divided by 3 is 3. 6 divided by 3 is 2. And we are still simplifying, and we're still working on question 3. If I simplify the numbers first, I can see that 9 and 12 can both be divided by 3. 9 divided by 3 is 3. I'm going to leave the x cubed there. 12 divided by 3 is 4. Now, I'm going to divide the top and bottom of my fraction by x cubed. So I'm going to get 3. Now, if I divide x cubed by x cubed, it becomes 1, so I don't need to write it. 3 times 1 is the same as 3. 4. Now, x to the power of 5 divided by x to the power of 3 is going to give me x squared. So x to the power of 5 divided by x to the power of 3 is x squared. Finally, k. Whenever you see anything that looks like this, have a go at factorising. It's almost certain that the top and bottom are going to factorise. So let's just have a go. I've got to find two numbers that multiply together to give me 10, and they're going to have to add up to give me 7. There's my 10, there's my 7. So I'm thinking 5 and 2, and that combination certainly works. Okay, so my top of my equation, I'm going to rewrite as x plus 5, x plus 2. And then on the bottom, I can see that I can take out a factor of x. So I'm going to take out a factor of x, and I'm going to write x times x is x squared, x times 2 is 2x. Now when I look at that, I see that I can divide the top and bottom of this fraction by x plus 2. Okay, we call it cancelling, and you can only do it when you're multiplying on the top and the bottom. Final answer, x plus 5 over x, written like that or even without the bracket for the top. Both are correct. X plus 5 over x.